But you start from a high energy and you go to a lower energy source. And that's really the same is true for your body. You have potential energy each time that you go to take a stroke, right? Store it in your hands, and then you pull through, and then you start again. And so you're always going from a higher potential energy to a lower potential energy, and you're losing the rest of it as heat. Basically what they do is, in this tank, they take a food sample. You can see we have pressurized oxygen. This is called the bomb, the little container inside. Lights it up, and in simple terms, we basically burn that food until it breaks apart. So how many calories, how many degrees of water that is raised gives us our calorie output. When we're burning a fuel, when we're actually taking like a piece of apple and we're trying to see how many calories are in it, what we're doing is we're breaking apart the bonds that made up that made that apple piece stay together. And therefore we can tell, again, the amount of calories in it, but we're using the amount of heat that's generated from breaking it apart. Right here, what about the structure of lipids allows us to be the most energy dense? Does anybody have any thoughts on it? We talk about like saturated and unsaturated lipids. I don't know if anybody has any chemistry background. Just take a guess.
Double bonds?
Bonds, a lot more bonds, double bonds. There's a lot more bonds in a lipid molecule, and so that's why they actually can harness more energy, because there's a lot more bonds to be broken. Because also there's more bonds to be broken, it takes more energy to break them down. So it's kind of a little bit of a catch-22. There's a lot of energy to be released from them, but it costs more energy to burn. As you saw in the breakdown of glucose, we made water. Okay. We also sometimes make water and sometimes we add water to reaction. And it's called hydrolysis and condensation. And I'm going to show you some examples of them in the next slide. But hydrolysis reaction are going to be helping to break down carbohydrates, fats, and protein. And they split the bonds. So hydrogen, water is H2O, so it's going to basically split it. And then condensation, just imagine condensation, you could think there's condensation in the air. It's going to do the opposite. So it's easier to show you. So here's hydrolysis. We are going to add water to break down, let's say, sucrose, which is a sugar. We're adding water, hydro water, to, you can see that OH and the H plus on the two molecules of glucose and fructose. Okay, so we're taking sucrose, adding water, which is in our body, and breaking it down to glucose and fructose, which are more simpler sugars. Because when we have a sugar that's a dipeptide, like sucrose, when it comes into our stomach to be digested, we break apart that sugar even further. We just keep breaking molecules down.